All right, welcome to Geek Time with Morgan Live. And today I thought I would try this live thing to catch up on some of the projects going on here at Geek Time Central, where we show you that anybody, regardless of gender and age, can do geeky stuff like batteries and whatnot. So I thought I'd just go through a few of the projects. You may not even heard of some of these projects because I haven't even had time to edit the videos and get all the videos out about the projects. But that's why live is awesome, because there's no editing, there's no censoring, there's none of that nefarious mind control manipulation stuff, like me moving the camera back and forth. You are getting very sleepy. Okay, so first up, let's see if I can switch the camera around. Like, oh yeah, there we go. Yay! Okay. Now, if I can actually use this device, cool. Here we have the first project. The first project is an easy flat pack bike battery. This is a nominal, well, they call it 48 volts, but it really charges up to about 52 volts. And you can see that I have opened it up. Normally it's inside this case, this black case, and it mounts nicely on the bike, on the bike rack, and has a key lock and everything. So it's a pretty sweet setup for just simple kind of thing. But, the cool thing is I have been charging this battery pack with the Grin Cycle Satiator, which I showed on another video, but maybe we could even run over and actually see it if we go through all of this maze here. So right here, lights on, laundry, all of that fun stuff. Okay, this is the Grin Cycle Satiator, and I mentioned it in another video. This is a universal e-bike charger, with one of the cool features being that you can program it with different profiles that allow charging your batteries not all the way full. And that helps with the lifespan of lithium quite a bit. With these lithium batteries, they actually don't like being charged. These are lithium manganese, and they do not like being charged all the way to 4.2 volts per cell. If you do that every time, then it reduces the lifespan. So what we do with the Grin Satiator is we charge this up to about 85%, which is about 4.05 volts per cell in each one of these cells. And that's pretty cool. But it also can cause a little bit of an issue, kind of a frustrating little issue, which requires a little bit more explanation of batteries, that today is going to be all about lithium battery management systems. So this down here, this board that I'm pointing at, is the battery management system. If you're not familiar with it, or if you kind of have heard of it and don't know what it is, what the deal is with this battery management system is these lithium cells, if we, in this pack, here's the negative lead, the negative terminal, this black one, it goes down and connects to these cells down here, and then the positive lead is over here. So if we put, let's say, 52 volts into this battery, so we're sending it 52 volts, and we're expecting it to be distributed throughout the cells. There are 13 cells in series here, and you might say that looks like more than 13. Well, there's both a series and a parallel thing going on here, and I'm not going to get into the details of that. But so there's series and parallel. Anyway, so you would, in some batteries like lead acid or even nickel metal hydride, the voltage that we send through the 13 cells in series would be evenly distributed, and they would equalize that voltage between them. With lithium, that equalization does not happen automatically. Lithium doesn't do that, and there's some fancy chemical reason that brainiacs with Nobel Prizes and all of that stuff understand that, as a former scientist, I don't, but whatever. Anyway, the fact is that since it doesn't equalize, you can get a situation where different batteries in this pack have different voltages. And so that is why for lithium batteries, if we want to have any reasonable lifespan at all, we have to have this battery management circuit, which, as you see, has these wires going to each one of the cells, each one of the cell units, the 13 cell units, to monitor what's going on in the voltage of that cell unit and making sure that it's equal with the other cell units. So that's pretty cool. And that's why, again, if you're ever going to do a lithium pack, you want some kind of battery management system that can actually balance out those voltages of your cells. And you can kind of see that there. Okay, so nice, right? So what's the problem, Morgan? Well, the problem is that when we only charge this to 4.05 volts per cell, this battery management system, a lot of these less expensive ones, are not designed to kick in and start balancing until above 4.1 or even 4.15 volts per cell. So this hasn't actually been balancing because I've only been charging this pack to 85%. So over time, some of the cells drifted way out of voltage alignment with the other cells. And specifically, these at the low end, at the negative end, this group of cells here was hovering at about 3.9 volts. The other cells in the pack were about 4.05 volts, where they should be. And battery management system does is it not only balances out cells, but it makes sure that you never discharge any of these lithium cells below a certain low voltage point, probably around 2.9 or 3.0 volts. I don't know what its cutoff is, but it certainly does have a cutoff, because if you take your cells below the cutoff, you can permanently ruin them. So these wires to each of the individual cell groups monitor not only the high voltage and balance them, but monitor the low voltage. And if you get any of the cells below their low voltage cutoff, then the whole thing turns off. You may have noticed this with lithium packs before, that e-bike packs and whatnot, that sometimes if you get them discharged too low, they just shut off. Whereas that never happens with like nickel metal hydride or other kinds of batteries. They just sort of slowly die. Well, that's because you've got a BMS circuit actually protecting that battery from getting ruined. So cool, right? Well, that's a good thing that we have that circuit protecting this. But the negative thing, the problem is that if one cell group, like this group here, starts out at a lower charge, a lower voltage, than everything else, then it's going to reach its cutoff sooner than everything else. And once it reaches the cutoff, the whole pack shuts off. Even if all the other cells have juice left in them, and you could, let's say, get another 5 or 10 miles out of your e-bike, well, because it's shut off, and you're done, because those are out of balance. And so that can be a bummer. I did a trip this fall, which was a very long trip, and both of my packs died about 2 miles from home, and my legs were totally dead, and I was kind of miserable. It would have been nice to have that little bit of extra. So that's what we're doing here today. We have, over at the other end of these wires, a little power supply, a variable power supply, and we have this variable power supply set at 4.05 volts. And I know that because I measured it with the voltmeter. This display is somewhat accurate, but not greatly accurate. So I actually dialed it into 4.05 volts, and then you can see the 4.05 volts is not enough for the whole pack, but it's enough for this one cell group that was below spec, that was out of balance with the rest. So we have the negative lead connected to the negative end of this cell group, and then the positive connected to the positive end of this cell group. And so we're basically bringing that cell group up to snuff so that it is balanced out with the other ones. And there were one or two others that were slightly out of spec, but not too bad. So that's what this project is doing. And the only negative of this project is sort of having to open up the pack like this, and then having to figure out this cellophane tape and all of that and replacing the tape to get it back into the box. So we'll see how that goes. That's my least favorite part of the job. I don't mind the electrical stuff. It's that physical stuff of taping it all back together that I'm not good at. Just like I hate shipping boxes, like packing stuff up. Okay, so let's move on to the second project, which is closely related. And in order to do that, what I'm going to do is try to not just show you a picture of my ceiling, but yay, whoa, okay. All right, so let's go in to the garage. And I have this on a gimbal and it's getting a little confused by all of the movement. It shouldn't be, it's supposed to not be confused by that kind of stuff. So here we are in the garage. Let's flip the camera around. Okay, so cool. Now here's our other project. Let me bring this up close to show you this project and then I'll explain what it is. This, my dear YouTubes, is a piece of a Chevrolet Volt battery. Now I actually happen to own a Chevrolet Volt, so when I found that I could buy pieces of a Chevrolet Volt battery, I thought that was kind of cool. And so this is out of a crashed Volt. You could buy these new, but they're more expensive. And these are designed to last for many years and lots of cycles and very high currents. So this thing is rated at 150 amps and it's around 48 volts. So this one, similar to that e-bike battery, is putting out a similar voltage range, although in here there are actually 12 cells in series and that e-bike battery was 13 cells in series. Now these are big rectangular pouch cells instead of those circular cells that are in that e-bike battery. So what is this for? Well, this project is all about putting solar charging capability in my trailer. Now, my RV trailer. I already had that capability with some of these GC2 batteries, but in the fall when we winterized the trailer, we forgot to unplug the charge controller, and then these got down to 0 volts. So I concluded at that time that these batteries were going to be dead and would not be recoverable. Now that may not be true, but regardless of whether they're recoverable or not, I'm actually doing a discharge test right now, so I'll report on that once it's done. I decided to embark on a lithium project. And what better than to use used lithium that would otherwise go to the scrap heap, the junkyard, the recyclery. Why not use this lithium in place of a bunch of big, old, ancient lead acid batteries and instead see if we can make this work? So there are a few keys to making this thing work right. As I mentioned with the bike battery, there is the need for a battery management system, which is what is sitting right here. This is just the display unit. This is the BMS itself. This is something that I ordered from China, and the very fancy title for this thing is the Bluetooth battery management system. It's just called the Bluetooth battery management system. So if there was ever another Bluetooth battery management system, then I think people might be confused. Which Bluetooth battery management system do you have? But the cool thing is that you can actually get an application on your phone. I was only able to find an Android, so I actually ended up having to buy an Android, a cheap Android phone, to program this thing, but it is programmable. You can bring up a display, and I'll show that another time, where you have all of your settings for your BMS. So what I'm going to be doing today is taking all of this pile of wires that came with the BMS and wiring it up to the individual cells here. Now let's see if I can take this cover off without zapping myself. 48 volts probably wouldn't be deadly, but it wouldn't be pleasant either. Okay. Well, anyway, I can't get that open right now without two hands, but underneath this cover is the series of connections for each of the individual cells. And then all in series added up, again, it's around 48 volts. So I'm going to be wiring that up, and so that I can use this BMS to monitor both the charging of the battery and the discharging of the battery. And then you might wonder what these other circuits are back here. Well, this one, I don't know if I'm going to use. It is a boost controller. So this one boosts 12 volts up to 48 volts. So I could theoretically use this to charge up the lithium battery from a 12 volt system. I might do that. This is a thing that turns off. So it's for 12 volt batteries. And if the voltage on the batteries gets too low, it turns off any current, any load from those batteries, which would have been helpful in the situation where they got drained. So that would have been cool. And then I have another circuit in the other room that takes the 12 volts or the 48 volts from this and converts it to 12. And my plan with this system is to actually interface this 48 volt battery system through that down converter into a set of, just like one or maybe two of these lead acid batteries. If these are recoverable, I'll use two of these. If they're not recoverable, I'll just buy a regular old 12 volt lead acid battery. And then I'll put this to basically feed or maintain the charge on the 12 volt when we're out and away. So that way I don't have to do all sorts of fancy gimmicks to try to rewire the 12 volt system in my RV. That would be crazy. Or I saw another YouTube video where a dude had a whole bunch of these converters that convert to 12 volts. Let's see if I have one here. No, I don't have one in the bin right here, but I do have one somewhere where you can get little converters